All right, welcome everybody. Another episode of Capture, Compute, Create. Today we have with us Gannon Wilder from Paracosm, as well as William Speakman from Caveo Consulting Engineers. We'll be talking today a little bit about handheld scanning and what you can do with the Paracosm solution. So during today's session, feel free, of course, to ask questions. As always, you can use the GoToWebinar widget on your GoToWebinar control panel there to ask us a question at any time. We may break in the middle of the session to take some questions. Otherwise, we'll save any remaining questions for the end. As you can see, we are recording this session. We'll be posting this to our YouTube channel within the next few days or so. And feel free to reach out to me directly if you wish, or any of us. You can email us at capturecomputegreat@autodesk.com. And then we'll just show you a couple of the places where you can find, the YouTube channel and other things. As I mentioned, feel free to check out any of this to get in contact with us, etc. So just to kick things off, I would like to give you a quick poll question. Just to get an idea of what sort of experience levels everybody has. So if you don't mind, let's just take a few seconds and give you guys a chance to answer the poll question. Give it a few more seconds. All right, that should be good. So it looks like most of you guys are pretty well versed with laser scanning. So this shouldn't be anything too crazy. So with that, Gannon, let's hand it over to you.
Awesome. Yes, thanks, Eric. Hi, everyone. My name is Gannon Wilder, here with Paracosm. Definitely excited to be with you guys today. Just wanting to introduce our technology to you, our handheld scanning system that we've developed. And so I'll kind of do this intro at the beginning. And at the end of the presentation, William from Caveo, he'll jump in, share some stories and use cases of how they've used it out in the field over the past year. As well as the workflows they've discovered to bring it into ReCap and Revit. But yeah, just as a quick background of who we are at Paracosm. We're a software company based out of Gainesville, Florida. We were founded in 2013, and it really all started seeing a new wave of technology, seeing that these depth sensors were becoming a lot cheaper and a lot more powerful than they have been before. And we saw that we could create software that enables people to scan and create 3D models from really cheap, low-cost hardware that wasn't available a couple of years before. So yeah, just using a normal tablet and a kind of a cheap add-on camera, you can scan any indoor space and bring those models directly into ReCap. And in contrast to the traditional laser scanning methods that you guys might be familiar with, as well as in contrast to just hand-drawn measurements and pictures. So yeah, in short, what we developed is helpful for anyone wanting to capture existing conditions of building. So if you're in architecture, engineering, construction space, whether you work on new building projects or a lot of retrofits. Anytime you need to have a detailed understanding of what is in the building or the job site you're working in, this handheld scanner is really useful to be able to pull it out, kind of one button operation, walk around, scan, and have a model. So yeah, I'll dive quickly into how the technology works, and then we'll let William take it over to go into the workflows. So what you see here is just a quick video kind of from the perspective of the scanner. So you can see you walk through a space, kind of like you're taking a video of it. You kind of move slightly slowly, kind of wave it around, upload it to the cloud, and our software produces this model that you see here. This is a point cloud that you see in Revit. Sorry, this is actually in ReCap. And you can see there's annotations on it. That's something that doesn't come automatic. But yeah, so it's a colored point cloud. And if you guys are familiar with point clouds, you know, this is nothing new, the output. What is unique about it is the data capture method, or the hardware itself. So our hardware is like I said, it was low-cost hardware. So this is a simple Microsoft Surface tablet. You can use multiple versions of it, the Pro 1, 2, 3, or 4. Typically, people you can source your own tablet, but we provide the depth camera to it. So the depth camera is a low-cost structured light sensor, and it enables you plug it in, you open our software, and how the scan process works is you kind of walk through like you're taking a video. This one button operation, press scan, press stop. Once you scan a space, then you upload it to the cloud. And the majority of all of our processing is done on cloud. So the scanning operation is mostly just to collect the data, and then the model is created. The reconstruction happens in the cloud. And then finally, you just download your point cloud format and bring it directly into ReCap. We have multiple data formats that you guys can use. The RCP or RCS native Autodesk file formats, as well as other standard point cloud file formats. So it's compatible with several software and kind of workflows that you guys are involved in. So yeah, just a little bit more detail on the scanning system is because it is handheld, it gives you a lot of flexibility in how you go around capture. You don't have to set up a single point, set up a lot of markers, press scan, wait 15 minutes, and then move location. It's markerless tracking, so we track based off natural features in the space. So you can walk through an environment, I've said this a couple times, but like you're taking a video, kind of slowly pan over everything, and you can capture it. One unique thing about it being a handheld system is you can kind of stand in the middle and kind of just do a quick pass of the whole room, or kind of like a small circle around the whole room if you just want a basic floor plan, or if you're wanting very precise coverage of specific pieces of equipment, other interesting items, you can move in and out and around, like in front, behind, to the side of any relevant objects you want to capture. So it really can fit your needs as far as how much detail you're wanting, whether it's a full, just a quick kind of floor plan overview of a space for a quick visualization, or if you want really detailed models to be able to draft on top of later. A couple other interesting things to note of the scanner itself. The scanner is a structured light sensor, which means we use the color camera, as well as infrared laser to scan the space. And what that means with the infrared limitation is it doesn't do well in very harsh sunlight, direct sunlight. So it's best in interior environments or outdoors in low light conditions. Another item is, because of the color camera, it also needs light. So you can bring, if you're in a very dark space, those add-ons to attach a flashlight, and it works great. A couple of use cases we commonly use it is above ceiling tiles. So with a flashlight, you can just stick it up above a ceiling tile, kind of spin it around, and be able to capture all that information instead of having to take down every ceiling tile in the building to capture that. You can just take out one, stick it up, spin it around, bring it back down. One other thing to note is the range of the depth sensor itself is about 12 to 15 feet, which means very, very high ceilings, anything beyond 15 feet it's kind of hard for 15 feet plus the height of a human holding it. So, anything above like 20 feet is a little bit beyond the range of the sensor. But as far as capturing space, we're not limited to capturing small areas. One unique thing about our software is that we're able to capture very large spaces. We captured upwards of 5,000 square feet of buildings in one pass. That's not standing in the middle and spinning in a circle, like I mentioned, the range. But you can easily walk around the facility, once again, like you're taking a video, just kind of walk around the perimeter of it and be able to capture it that way. A couple other interesting things to note is because, like I said, you can capture very large areas with this. This can be a standalone solution, or it can also be used in conjunction with traditional laser scanners that you guys have. So if you guys are used to working with laser scanners, you can use this to kind of fill in gaps, and that's what a couple of handheld scanners have focused on, or that's all they're capable of doing. Or you can use it fully as a replacement of laser scanners on some projects if needed. So you don't need to bring out your tripod unit to a site. The guys can just have a couple of these handheld units and walk around and capture the whole area. So that's a really unique feature about us, is being able to capture those spaces and still have it be a handheld unit. So yeah, we're going more into the details on how the different stories that, different projects we've used this on, as well as how it works in ReCap. I'd like to just hand over the reins of the presentation to William, and he'll go through their experience and struggling with kind of working with laser scanners as well as traditional survey methods, and as well as their workflow that they're currently using with our system. And then we'll open up some models and ReCap and show you guys kind of what the data looks like. So I'm switching over to William right now.
All right. Hello, everyone. My name is William Speakman. I am from Caveo Consulting Engineers. We are a design and consulting engineering firm that has been serving the healthcare industry for a little over 11 years now. As an MEP engineering firm, one of the things that we, by our own nature, do is, well, we focus a lot on the quality of the product that we deliver to our clients, not just because, as I said, it's a company that employs engineers, so we're fairly methodical, but also because we're very cognizant of the sensitive environment that we are actually designing for. As I'm sure you can imagine, with the healthcare sort of environment, if you turn over a product that actually isn't up to par, then you're impeding the ability of the owners of those facilities to actually operate them effectively. So with that in mind, here at Caveo, one of the things that we pride ourselves on is actually looking at the BIM process as it is currently implemented and trying to find ways to implement it more effectively. In the spirit of that, we've been kind of looking for a way to augment the front end of the BIM process. So I'm sure you all are aware that the BIM process is only effective when it is, or cost effective when it's implemented effectively. And for the most part, if you have a good BIM manager, that's all taken care of once you get into the office. But an area that we felt wasn't addressed very well was the actual front end work of capturing the infield conditions. So just to tell you guys a little bit more about Caveo and why we sought out this solution, I'd like to take a couple minutes to do that. So Caveo has two offices, one in Denver and one in Charlotte, and we share the workload. So there are times when we will have engineers and drafts people working on jobs that are in a completely different state that they've never seen. And so one of the challenges that we ran into when we moved from the traditional CAD sort of structure over to Revit was the level of detail that comes along with that, and actually meeting those expectations. Just to give you an example, this is a hand-drawn survey of a boiler room, and then on the right you'll see the final product. So, as I'm sure you can imagine, there are a significant amount of obstacles that make it difficult to translate this hand-drawn survey over to this 3D model. And so we began searching for kind of ways to augment our survey process. We are a medium-sized firm, and we were aware of laser scanning, but in part due to the high price point and limitations that come along with it, and also the preferences of our clients, we were kind of, that didn't look like it was a viable option for us, and I'll go into that a little bit more later. So we began exploring other methods of augmenting this hand-drawn survey process, trying to take photos and cross-reference them in, but the engineering team that had never seen the site really couldn't make any sense of that. Also, sort of taking videos to try and provide some context, but that really didn't do the job either. And finally, talking about laser scanning. So the challenges that we found with laser scanning were the price point was really high. So as a medium-sized firm, we couldn't justify that for just one project as a purchase, and renting the service even for a day or two is fairly costly as well. The second piece that we found to be sort of troublesome, based on talking with people that we worked with, was you'll get scans that come back that are so dense that they can only be handled by special machinery, and there's quite a bit of processing once it comes back from the field. And then finally, the laser scanning methods that are currently employed are very obtrusive. They require a lot of setup. There's an actual team that goes in and a tripod, and they have to set up markers, and in some cases clear out the space. And as I'm sure you can imagine, for an occupied healthcare environment, that just didn't fly. So having exhausted all these options, we kind of kept looking around, but really weren't having much luck until February of 2014, when we ran across Paracosm and their handheld scanning solution. And we began working with them to try to tailor this to the AEC industry and streamline that workflow. So since then, we have completed over 800 scans across 23 different job sites, and we've identified a number of advantages to handheld scanning as compared to laser scanning. So just to touch on that really quick, the handheld scanner actually attaches to the Surface tablet, as Ganna mentioned previously. This is especially convenient for us because we just attach it to the tablets that we take out into the field to survey. And during the survey process, as we're taking notes and that sort of thing, we can just fire up the scanner and scan a space. And then when we get back to the office, we set the tablet up and upload all the scans to process. Another neat advantage to this, their scanning solution in particular, is that while it's capturing a 3D scan of the space, it's also capturing a video of the space. So any tagged information that we would want to review later, that sort of thing, or if we need to go back and actually review some sort of media where we would have looked at pictures or whatever else before those of us that actually surveyed the site to kind of update our notes. We can now just look at the video that we capture simultaneously with the scan. The fact that the scanner is handheld provides a great deal of flexibility in how you can capture point clouds of a space. So Paracosm scanner, we found, can be used to capture an entire large area or just a specific area in question if you're going out and sort of keeping track of iterative updates during the course of a job. There is actually no setup process with this, so we're literally able to just turn the scanner on, like I said, and fire it up and scan. We don't have to put markers up or set up a tripod or anything. So that's very convenient as well. And then one of the best selling points for us in our particular market was that it's unobtrusive. So we're able to, with the same level of coordination with our client that we would normally have to actually go in and do a survey, we're able to have that same level of coordination and go in and do a survey and capture a scan for use during the design process back in the office. We've found that not only can it capture a large scope, I think the largest single scan that we've done to date was in excess of 2,500 feet, but it can also capture spaces that you would have some trouble getting to with a laser scanner. So Gannon mentioned earlier that it is very useful for capturing up above the ceiling. So we're able to scan below and transition up above the ceiling, and also get into narrow spaces in mechanical rooms and the like that would be inaccessible to tripods. Because of the mobile nature of the scanner, we find that it is faster to actually acquire a point cloud of a space because it's being done simultaneously with the survey process. Sometimes we have engineers go out and do the survey process on their own and have a separate person go along and do the scan, but it's also possible for, and in many cases we find ourselves doing this, to have the engineers that go out actually, as I said earlier, document the space and then fire up the scanner and take a scan of the space. So it's very convenient in that sort of sense. Finally, the cloud-based nature of the handheld scanning process allows for a number of items to happen after the scanning is complete. One of the neat sort of solutions that this offers is if you have multiple scanning units, you can actually have a couple people go out to a site and scan simultaneously, and provided that the areas overlap, they can be combined once they're uploaded and processed. And that combination happens automatically without any sort of markers or anything. So it removes an element of human error. Likewise, if you're just a single person scanning a space and you'd like to see a larger point cloud than just the individual point clouds that you capture, those can be combined afterward as well. And the post-processing, once it's uploaded, actually optimizes the scan. There are, well, if there were any errors, unless they're egregious ones, for the most part, it's able to optimize those, for lack of a better word. And finally, as you go through the course of a job, as I mentioned before, you're able to actually come back and update sections that you've scanned previously. So you can go out and just scan where new work has been done, and then upload that and have it be combined with the scan from a previous date. So what we have used it for at Caveo has been primarily to augment the chain of communication between the field and the office. Because of the price point and the accessibility of the scanner, we are actually able to implement this across a large number of jobs. So rather than just having a certain job where the complexity of it would warrant hiring a laser scanning team, we're able to, as long as the scanner is available, take it out and capture the space and bring that back and then have it virtually live in the office, which for us allows the designers that aren't on site to actually go into the space virtually, and also if there are any sort of items that are overlooked during the survey process, or if there are any details that aren't clearly communicated prior to the survey actually taking place, that same capability to revisit the site virtually allows us to address those more often than not. So, all that being said, some other benefits that we've seen from it, leveraging the 3D scans of the spaces allows us to accurately input existing conditions, which then results in designs that are far more reliable as the job goes forward. I'm sure we've all heard of the phrase garbage in, garbage out. If you don't actually take the time to make sure that your plans are verified and accurate before you start the design, more often than not, you'll have to go back and redesign portions. And that is actually, well, that eats into the cost of the project, or eats into the budget, obviously. So anytime that can be avoided, that's a plus. You get more accurate measurements. We've actually used this to not just to measure like the height of pipes and ducts and that sort of thing, but also to measure clearances from panels and to measure spaces to make sure, or to aid in the selection of new equipment. We're also able to revisit the site virtually, like I said, and do sort of a field verification of existing devices or devices that were installed if the scan is done after a punch, without having to make a return trip to the site and answer questions that come up that way. So, just to talk about some of the actual use cases that we found in the field, we've actually found that that using the scanner allows us to go through and, I'm sorry, one second, I'm having a little bit of trouble pulling up the model that pertains to this portion of the presentation. There we are. So we've actually used the scans to go through and verify plans, and that allows us to catch some of the errors that would be overlooked otherwise. For example, this scan overlaid here actually showed an offset of it's a little over 6 inches, right at about, which seems pretty minimal, but when you're actually trying to make sure that you have the clearances for your panels, it can be a pretty big deal. And also because you know, the client is actually trying to have a BIM model that that is accurate for their use in operations. Catching little stuff like this prevents errors further down the line. The next example that we have was capturing a large area and using that to do some verification after the fact. So here is the scan that I mentioned earlier. This one scan of this area we were able to capture, and it's actually been trimmed down a little bit just to kind of clean it up for the presentation. It was approximately 2,500 feet, and which for a single scan we were very impressed to see that come off of a handheld scanner. I wanted to include this just to kind of give you an idea of the actual scope that it can cover, and also one of the neat things about this project was for this building, we actually scanned from floor to deck throughout the entire thing, and some scans have been removed that weren't relevant to the project scope at the time, but if you actually go in and cross-reference the plans with the scans overall. I think I may have opened up the wrong model, but that's okay. You kind of get the idea. You can actually see the various runs of pipe and duct, and go through and confirm things that way. It was this same scan that we wound up having some questions about, having to kind of go back through and verify some things after we had already left the job site. In this particular instance, I suppose that wouldn't have been a horrible thing, but we do have jobs from time to time that are in excess of 3 hours away. And so making those return trips for something that minimal is kind of counterproductive. So being able to just go in and if there are questions, like in this case we had about the receptacles that had been installed, we can actually go in and just say, oh, well, there's one, and if we and cross-reference that with the plans, and if we need further clarification, we're able to refer to the video to see the specific types and that sort of thing. So let me hop back over back to the presentation. Our next use case was actually one of the ones that I'm most proud of, and I actually I don't have this model open right now, but I'm sure you guys have had the experience of working with a new process and implementing it within your company, and then sort of shepherding that. So this job came up several months, many months after we had started doing the scanning, and I had received requests for scans of areas and that sort of thing because people had found them helpful. But this instance, or in this instance, we were working on a mechanical room and having to replace an air handler unit, and the routing was particularly complicated. And I'm actually going to be kind of vague on the details because I wasn't directly involved with a lot of this. But so we spent a good deal of time kind of communicating back and forth, as I said, with pictures, and also having meetings between engineers to discuss, because the people who were designing it weren't on site. So a request was put out for a scan, and I went out and did the scan and brought it back. I guess to clarify further, this job had already been underway for a while, so it hadn't been just rolled into this scanning process. So I went out and did the scan and uploaded it, and the engineers were able to take a look at the site and resolve the routing issues, and also apply it on the electrical side to place their panels, or to correctly place their panels without input from myself, which I was, particularly pleased to see. So I have, I think, one or two more examples for you guys. Let me just see really quick here. The boiler room that you saw at the beginning of the presentation is actually right here. this was one of the first jobs that we did with the scanning solution with Paracosm's handheld scanner, and in this case, we were actually using the scanner not to document existing conditions, but actually to record as-built conditions and modify the plans to suit. So we actually went in and did a scan of those areas, and then were able to open the job up or to import the scan into Revit and just begin correcting the design so that way it actually matched what was in the field. And just to kind of give you guys a sense of how that looks, I've included that here. There's actually a video on Paracosm's website, and I believe on our website, that shows a little bit of this process. And I'm sure there will be more material released that covers that in the future. But all that being said, I guess that sort of brings us to the end of our from the field portion of the presentation. If you would like to contact us, if you have questions, I just thought it would be a good idea to throw this slide in, so that way you could have Gannon's email and myself. And with that, I'd like to turn it back over to, suppose, Eric, you officiate the question and answer session?
Yeah, hey, so thank you for that. That was great. So we do have a couple of questions that came in.